So please, very crucial topic. We good to go? Okay. All right. Hi, everyone. Very good. So I'm going to talk about PSGI and Plaque for fun and profit, but mostly profit. I'm Sawyer, as you can see here. And I do want to give a little bit of warning. I'm going to talk a bit about Perl. I'm going to talk about web, which is very annoying. But you don't actually have to know Perl in order to enjoy this or to learn from it or to sit here. And hopefully at the end, I'm going to give a few bits that will be interesting enough to sit through the entire thing. So we'll see. I'm actually happy to be here and talk about stuff that I'm very excited about that nowadays I get to do, which is working with some really cool technologies. One of them is PSGI and Plaque, and I'm going to focus on this. A lot of you probably don't know me, hopefully for you. I'm Sir X, and I hack on Perl. I work at Booking.com. I maintain a lot of stuff like module starter, which helps write modules, helps you scaffold a new module if you're a beginner in Perl. I maintain Dancer 2. I'm a maintainer of Dancer 1, which is a web framework for Perl. It's very small. It's very nice. I wrote a lot of weird Perl-bound plugins, which is a reverse proxy written in Perl, originally by the guys from LiveJournal. I wrote an interface to XKCD, which is a fantastic comic strip, and it's both synchronous and asynchronous. It's kind of nice. I wrote this nice little module that is kind of like our Chuck Norris facts about Raffle, which you probably don't know, but if you'll go there, you will. And I tend to yell, I tend to scream, I tend sometimes to code. You can find me on MetaCpan, which is the Perl interface for CPAN, which is a bunch of mirrors for replicating code. We put all of our code in CPAN. This is where you download it if you're a Perl programmer. And you can see my author page here. Of course, I also wrote an interface to that because MetaCpan uses Elasticsearch and has an entire API. So this is an object-oriented interface to that. And I do have Twitter. I do have GitHub, yada, yada, yada. OK, so what is this talk really about? I'm going to start with talking about this protocol called PSGI. And I'm going to explain it. And then I'm going to go into Plaque, which is a toolkit that we use for PSGI. I'm going to talk about the different business considerations you have in large infrastructures. And I will use Booking.com as an example. And I will talk about how PSGI and Plaque actually tie in with those business considerations and why it actually matters to discuss big infrastructures when we talk about new technology. PSGI and Plaque is actually derived from Ruby that had Rack or Python that has WSGI. They are both interfaces that were written in other languages. We have it from there as well. It's called PSGI. If you're familiar with WSGI or Rack, this will not be new to you. But if you are not, this will be new to you. And hopefully, I will explain enough that you would understand. And this knowledge will transfer all the way to Rack and WSGI if you ever touch Ruby or Python. Hopefully, you won't. So first of all, the structure of PSGI is easier to explain once we take a look at how a regular web application is actually structured. There are two common structures. One is when we have, this is my ultra awesome ASCII skills. We have a user, and usually I draw them with a balloon, but I didn't know how to do that in ASCII. So you have a user that goes to a server, for example, Apache, and that has a handler, which is your actual application that calls your web application. So the handler is kind of like the mediator to what the server sees as the request and response objects. So the server, when it has a request, it represents it in whatever object it has, and then it transfers it to your application. Your application needs a mediator that can understand that. This is the normal CGI style where the actual application is sitting outside of the server, and it's calling an external one to reach it. This is a structure that we're more used to with time, which is kind of like mod Perl, mod PHP, mod Ruby, mod Python, what have you, where what we have is the Apache web server that internally runs an interpreter. It calls the interpreter internally, which goes to an application. And what happens is that if you take a look at the problems that we have with these, in this case, this is like CGI, fast CGI. Your application needs to know how to handle that. Okay? If you're using CGI, you're probably familiar with the fact that the first output that you have, it's in two chunks. The first chunk is actually headers. The second chunk is the output. And you need to know this when you output. If you're using this structure, you're using probably mod Perl. We'll be using mod Apache that gives you an interface to all those objects. And you have to know that you're locked into that Apache environment. It's a mess. PSGI can be set up in the same way. We would have I'm going to use the cursor anyway here. You know what? Fuck the cursor. I'm going to use the pointer instead. I tend to curse. So the server goes to a PSGI handler, just like in other places. But the difference here is that the handler doesn't care where you come from. It's not an Apache handler only. It has various handlers. I'm going to show a few examples. What it provides you is a really nice layer to accommodate any server that is going to send you a request. And it's going to translate it to a standard PSGI request. And I'm going to show an example of that. If you're sending it up internally in the web server, like, for example, on top of mod Perl, you still have a PSGI handler that translates the mod Perl into a proper PSGI request as well. In effect, your application will always have the same kind of request. You will always respond with the same kind of response. And I will show this. So, you know, examples always work better. And this tends to be confusing when we talk about web server configurations. So fuck that. Let's talk code. This is an example of a basic PSGI application. You provide a code reference. Okay? It's just a piece of code. What's going to happen is that your server is going to take that piece of code, hold on to it in memory. Every request that comes in, the server will send to the PSGI handler. It will translate that request if it's Apache, if it's version 1, version 2, if it's Nginx, whatever it is. It will translate it to a PSGI format, and it will send it to that piece of code. Okay? So your code will get the request. Every request, this piece of code will be run. And this piece of code will always be called with the same parameters. Always. Exactly the same on any server. In this case, we actually get an environment hash. It's a hash reference. And it presents all of the environment variables that you have in a request. This could be the remote address and authenticated users, headers. Everything is in there. When you return, you have to always return the same thing, which the handler would translate to how your server expects it to be formalized in. So if, for example, you're running on CGI, and it's supposed to output it all to standard output, and you should not have standard error, because that goes to errors, to the error log, and you're not supposed to exit anything other than 0. It's kind of crazy stuff. You don't have to worry about that. If you're using mod Perl and you have to use the mod Perl Apache handler request responses thing, you don't care about that anymore. The handler will translate this little thing that you return to what it should be according to the server. So from this point on, you don't actually care about the server at all. You get this environment hash ref, and you return this array ref that has the exit code, it's the status, the headers, which is just pairs, and your content. And you can also return, IO handle here is basically a file handle. So you can return a file handle object, you can return actual content, whatever you want. And it will translate all of this to a proper response object according to whatever server you're using. So for one server, it translates this way, for another that way, and it doesn't really matter. PSGI, however, actually supports some more advanced stuff. For example, delayed responses. Delayed responses is when we have a request coming in, and our thread is handling this, but it will take some time to generate that response. Basically, that thread is now stuck, and it can't receive additional requests. So what you do is run it multi-threaded, you fork it, all of these things. That's how we're used to working. But what if you actually want to run in an event loop? You want the event loop to actually handle this, and you can receive additional requests in the same process. Oftentimes, processes are actually not bound by CPU. We're actually waiting on network a lot. And if we can delay the network and make that synchronous, that will be a major improvement. Oftentimes, event-based programming can be way faster than forking because you're not actually bound by the operating system. You're bound by network waiting to receive more and send. So this is a bit more advanced. It's kind of confusing. But basically, if you know Perl, it's not too confusing, where you have an environment hashref with all the information that you need. It will contain all of the headers and stuff like that. Instead of returning a response, which is, I already know what my output is, I know what the status code is, I know what the content is, instead what you send is another piece of code. It's a callback. So when I do return sub, I'm actually saying, hey, you know what? I don't know what it is, but I'm going to send you a piece of code that when you run it, it will tell you what it is. And that piece of code receives an object, a responder, which I can later use to send it the information once I have it. It's a bit more advanced. You don't actually have to follow all of this. An even more interesting feature, and I don't know why the syntax hiding is not transitioning here, but this is the streamed response where I actually don't even have all of the output yet. I just have some of the output, and I want to spoon feed the client without getting the thread stuck. So I respond with the status, I respond with the headers, and from this point on, I can just write and write and write with every new chunk of output that I get. When I'm done, I can close it. It will close all of the sockets, and that's it. And on a single thread, I can serve as many clients as I want, as long as my server can handle it. Very, very cool features that some servers actually don't even support yet. Now, this is how Plaque is written. It's a very nice protocol. If you want to write web applications with it, it's really cool. You don't actually have to write all of this stuff. It's good to know it, but you don't have to write it. You can use a web framework to use it. So for example, Dancer, which I showed, it works with this. It gives you some nice syntax if you Google it. And that nice syntax translates to this really weird code. And you just write get/ do this thing. And it will translate all of this for you. Now, if you want to use it for work, that's really, really nice, but you're not going to write in pure PSGI. There's a bunch of utilities that we have to handle writing PSGI, and not just the web frameworks themselves. There's a bunch of utilities that the web frameworks themselves even use. The toolkit is called Plaque. So it's made out of various components. There's handlers. Handlers are basically adapters to translate what a server sees as a request to what a server sees as a response versus the PSGI protocol. There's the runner, which is just a command line. You load stuff, you run stuff. It's really nice. There's a bunch of middlewares, which are the most awesomest thing in the world. There's the builder, which is some nice syntax in order to bundle all of these middlewares with your application. I'll show that. And you can even write a bunch of tests for it very, very easily using the Plaque test, which comes with Plaque itself. So going over some of these. Handlers basically connect your PSGI application with a web server. And as long as there's a handler for it, it will work on that web server without you caring that you're running that web server, which means that your application is running on Apache 1, Apache 2, CGI, FastCGI, Nginx, Lydie, and so on, and you do not change a single line of code in your application. And you do not care what server it's running on. That's all. So examples are Plaque handler Apache 1, Plaque handler Apache 2. These are server specific. There's also handler Starman, which is for even Perl-based servers, because it's that simple to write stuff now. It's no longer a challenge. So you have Perl-based web servers that are super fast, and they accept PSGI applications. It's just a code ref. So it accepts that code ref. Every request, it runs it. That's it. Twiggy is an event loop-based web server in Perl, which means that I have an event loop running, and then I can write asynchronous code in event loop in Perl, and it will run in the server, which is also written in Perl. Really nice stuff. Really, really, really nice stuff. I'll give you one small example for how cool this is. I tend to write services. One of the tricks that I use is that I will write a service written in any event, which is an event loop that Twiggy is running on. And what I'm going to do is embed a web server inside it for introspection into my service. So you have a service that is asynchronous with an asynchronous web server built into it for introspection on a running process. Not bad. Not bad. And there's, of course, handlers to deployment protocol. So let's say, well, it is a deployment mechanism. So the CGI protocol, the fast CGI, and that means that you can run CGI on whatever it is you want, of course. And then it's agnostic to the web server itself. It's how you use it. The CLI, just a few examples. The command line that comes with it, the Plaque runner, is Plaque app. Plaque app basically says, give me a file. I will run that file. It will return this nice PSGI application in a code reference, in a subroutine, and I will run every request on it. So Plaque app in a specific file. The PSGI is just common extension. It's actually a profile that's supposed to be that my app equals sub. You can even ask it to run specific servers and give it some information that it will pass on to the server. This is an example of asking it to run an application out of my app.psgi and run it on fast CGI with a Unix socket, and some other options for fast CGI and stuff like that. It's a very nice application. Middlewares are one of the coolest fucking things you have in Plaque and PSGI. Middlewares are basically this nice wrapper around your application. So suppose you wrote an application and you used common syntax in a nice web framework, right? You can attach to that these layers of additional functionality called middlewares. And you can add as many as you want, OK? Middlewares can do three things. When a request comes in, it hits the middlewares layer by layer. The first thing they can do is add information and send it onwards. So for example, I can add another header. I can remove a header. I can change stuff coming in a request before it hits your app. You don't actually know that I did this. The second thing I can do is change the course of action. So I can decide that I'm not going to send it onwards. I'll give you an example. I can decide that you came into a resource that is not authorized. So I'm basically sending your response back, no. And it doesn't reach the app. Your application doesn't care. I just provided authorization outside of the application. And because it's a nice thin layer, I can add it on multiple applications in a lot of places. And people started releasing general middlewares that you can add to your application if you want. The third thing a middleware can do is change what's going out. An example that covers all three is caching. Okay? How does caching work? I get a request. I decide if it already exists in my cache. If so, I respond right away. If not, I send it onwards. When it comes out, I save it in the cache, and then I send it back. I can do all of that in a middleware. A middleware waits for a request to come in. I check it in my cache, whether it's on memory, on disk, in memcache, wherever you want. If it doesn't exist, I'll send it onwards. When I get a response back, I'll save it in the cache and return. If when you come in, I already have it, I will just return there. I won't send it to the app. You just received caching without having any of it being built in your app. Your app just got free caching. And you can add it automatically to all of your applications. And your app doesn't have to change one single line of code. That's not bad. Okay? That is really, really awesome. I'll give you some examples of middlewares that I like. There's Plaque middleware rewrite. How many of you have used rewrite rules, right? Those are a pain to write. They're a pain to maintain when you have a large infrastructure. They're a pain to move to different servers. So, OK, you've written one. Now you have to move it to another. Oh, it's an htaccess. No, that's not supported in Nginx, and so on, stuff like that. It's really, really annoying. But you can write all of these in a middleware, and now your application gets rewrite. That's it. Cache, I gave an example. Debug. Debug is a middleware that when data comes out, it actually adds more JavaScript and HTML to the output to provide a panel with introspecting options. It's insane. There's a middleware for reverse proxying. There's a middleware for basic authentication. If you've ever used AuthBasic, it's an authentication mechanism, the one where it just pops up a username and password, and you have to type it in. It's really old school, but it's very, very good. And we kind of exchange these with login forms where you do this, because login forms are easier to maintain in the application. But AuthBasic allows you to do it in the application instead of htaccess file, right? Which is amazing. You don't have to maintain a .password file in your system, or secret, or whatever they give in examples. This is the DSL that we have for adding all of these together. So Plaque Builder, you have your app, whatever it is. Let's assume that this sub here is replaced with your awesome, nice web framework syntax. And what you do is call builder, and you ask it to start adding layers. So you say, the first thing I'm going to enable is foo, which it will autocomplete to Plaque middleware foo. Then you enable bar. And you can even send some options to bar, how it's going to add it. And it's going to expand to Plaque middleware bar. Then at the end, you give your app. So basically layer 1, layer 2, as many as you want, all the way to your application. The application doesn't know about middlewares that are before it. The middlewares don't know about any middlewares that are before or after. They just get a request, decide whether to move it forward, get a response, decide whether to return. There's an example of using some of these. Rewrite middleware, these are options for rewrite. So the options rules, which is a subroutine that's going to run for every request with your code for rewriting stuff. So this says, well, you can just try and this basically does a search and replace /foo become /bar. If you can do that, return a 301 with this. If you can't, try to rewrite /buzz to kooks. And if you can do that, return a 301 with that. It doesn't go next to the app. It will just send a request back to the user, please come back into this new path. And if the request is actually to fave icon, return a 201. Just examples. Auth basic will get authenticator as an option, and you send it to, this is a subroutine reference, so basically send it to this piece of code that will actually try to authenticate a user. Really nice. This is an example for static. There's a middleware for serving static files. So it doesn't go all the way to your application, because the more you go in, the slower it will be. So this actually serves it even before. It says, if anyone asks for /images, /js, or /css, serve a static file from htdocs. That's it. Very nice. Some testing examples. I'll use 2 modules here. Plaque test is what Plaque gives us for testing. HTTP request common gives us these functions for creating request objects, like get, post. I'm going to set up the dumbest small application that just returns 200 with content hello. I'm going to use Plaque test to create a test object. And what I will do is call request on it with this get function that I got from HTTP request. It creates a nice HTTP request object. It will feed that in, and it will return an HTTP response. What you see here is mocking an entire web server request cycle without a web server. This is insane stuff. Have you ever tried to write tests for your servers? It has to be up. You have to run it. You restart it. You're changing data. You have to change to a fake database. You have to have that code in your application to change to that fake database. It's just really messy, critically insane shit. And this actually lets you run an entire app faking a server, faking the request, faking the result, and you're using objects for a request and an object for a result. So you get entire introspection. So I get a result object. So I can say, well, what is the content? What is the code? Is it a redirect? Stuff like that. It's just an object with data. The test, when you send it a request, it will fake an entire cycle that calls your application as if it's under a web server and a user made a request. Crazy stuff. Today I wrote like tens of those today. It's really nice. So overall, this technology is really, really, really cool. And if you take a look at some of these web frameworks, they look exactly like you're used to writing web frameworks, web programming, except that they don't actually care if it's an Apache or if it's in Lydie or whatever it is. There are really, really nice stuff to it. So it is it's a powerful protocol while being stupidly simple, actually. It allows you to standardize all of your frameworks and all of your servers. So suddenly, a framework doesn't have to say, I have an adapter to this or that. It doesn't care. It always returns the same thing. Everything is fine. And that means that you can standardize servers. So now you can have really, really, really cool web frameworks. I suggest looking into Dancer 2. There's Amon 2, and there's Catalyst, and there's Modulicious, and a lot of these really insanely awesome web frameworks. But it also means that you can have cool web servers. So Starman, which is really fast. Twiggy, which is running an event loop. I wanted this for a really long time. The question, though, and this is kind of the other part, is this enough to actually move to a new technology? You know, if you're running on buzzwords like, I don't know, Hacker News, you basically have a problem where cool is not enough. You can't run your entire company on the cool factor, because it all boils down to the B word eventually, business. Which is, I know, it's a bad word, but when you're a big company, this actually matters. Some of the stuff that happen in large infrastructures, or things we think happens in large infrastructure, would prevent us to start working with new technologies, first of all, we assume that we're going to have to rewrite everything, and we assume that it's OK. I know a lot of companies that actually started rewriting their code every time they moved to a new thing. So they were on Perl, they rewrote to Ruby, they rewrote to Python. It's all great, fantastic, except that these things actually have a really big cost. Rewriting, refactoring. You can't just do, I'm sorry, you can't just rewrite, you can't just refactor. These things matter. It takes time. It takes a lot of time. If it takes you 2 days to fix a bug in code that you wouldn't want to touch if no one paid you to do it, but it would take you 2 months to rewrite it, is it worth 2 months if it takes 2 days? Not necessarily. Maybe it's not worth refactoring. Maybe it's worth to keep it as like really disgusting code. Maybe it's worth not rewriting it because it will take you 2 months and you're going to touch it every 7 years. Who cares then? You're not going to rewrite it. So we assume, oh, we'll just rewrite it. That's a problem. Code that makes money, no matter how ugly or uncomfortable or how old it is, it makes money. You can delete it. You can't remove it. You have to keep it around. Setups cost. It takes a lot of money to set up an entire mechanism for deployment, for rollback, for keep your code, your authors. It's a lot of setup. And these setups cost. And if you change those, they actually cost even more. This is something that a lot of developers will actually ignore this because DBAs will do it. And sysadmins will do it. And we think it doesn't exist because of that. But it does exist. And that's why a company can just, well, we'll just rewrite it, or we'll just move to this new framework, or we'll just move to this new thing. This is a problem. The question is, how does all of this actually fit with PSGI and Plaque? Why am I going to talk about PSGI and Plaque if it's not a trivial task to move to this, which we did? I'm going to use Booking.com as an example for this. Booking.com is a big company, close to over 500,000 properties, over 207 countries, 700,000 average room nights booking every 24 hours, over 40 million guest reviews. This is insane. These are users going on the website and adding a review to a hotel or some accommodation. Over 8,000 people work at Booking.com. We support 42 languages. How many websites do you know support 42 languages in 207 countries? So our IT is over 600 people. 8 of them, over 8 of them, are actual core Perl devs, people writing the language Perl. It is the company that hires the most core devs. I don't know if I mentioned this. We are hiring. You don't actually have to know Perl to work at Booking, because if you're hired, you actually start learning Perl as part of your job. So the code base of Booking is actually a very interesting example. First of all, it is massive. It is huge. Millions of lines of code. Packages, or otherwise known as classes, are over 8,000. Okay? Booking started at 1996. That means that some of the code actually depends on things that existed then, that either don't exist now or have been replaced with newer stuff. Some of this code, not all of this code, but some of it might use an ORM called class DBI. It's pretty old. There's a new one since 2005. Some of it uses Mason, which is an old web framework. It started in 1998. HTML template, which we actually rewrote to be much, 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 much faster. Some of our code actually relies on specific servers, systems, specific platforms. For example, Apache, which started in 1995, well, Mod Pro, Apache started in 1995. You know, when Booking started, Apache was like the newest thing in the world. A lot of things didn't even exist when Booking already had a few years of code. Think about that. It's a company that some of its older code uses stuff that didn't even exist when they started writing code. It's crazy. ModPerl, the first email I saw of ModPerl's mailing list was February 2000. This was 4 years after Booking already wrote code. It's 4 years of code, and then ModPerl came in. So if you want to move to new stuff, because I honestly hate everything you saw, with a vengeance. I really don't like it. Now, if you want to move to new stuff, you only have a few options. First of all, you can rewrite everything from scratch. I've seen companies do that. A lot of them are failing at it because rewriting is not simple. which I'll show. You can write your new stuff in new frameworks, keep the old stuff running, and your third option is to forget about it and stay stat forever. Let's go over these. First one, rewriting from scratch. Rewriting from scratch basically means a substantial downtime for the company. The more code you have, the bigger the downtime. Or you can hire at least 2.5 to 3 times as many developers, right? Because half of them will have to convert the code, right? Half of them will have to continue writing. And you're not taking into account all of the infrastructure that they're using. So all of the libraries and all of those stuff as well will have to be rewritten. Right? Half writing old stuff, half writing along current devs on the new system. So you have to add 2.5. Right? It's crazy. All the tools, all the setup, everything has to be recreated. So it is just close to impossible. I've seen a lot of companies fall because of this. You can write your new stuff in new frameworks. You will need multiple environments. You will need multiple. You could have multiple frameworks at this point. You will need a lot of compatibility layers. So cleanups, checkups, fixups, all of these layers that kind of mitigate and mediate between all of these old ones and new ones. And you will need a lot of heavy emulation. So you're going to have to fake different environments. So the old stuff, think it's still under old stuff. The new stuff will work just fine. But you will need to emulate. And eventually what you get is simultaneous development, where you can develop in the old stuff and in the new stuff at the same time. We do it, and it works really well. This means that you will have no downtime. This means that you will not need to double or triple the number of developers that you have. If we have over 600 in IT, this will not be easy to do, to find 600 to 1,300 or 1,200 more people. It's not going to be very easy. So this is kind of difficult. I'll explain. And of course, I did look into this option because I wanted to be very thorough. So if you do this, the third option, it's boring, it's depressing, and it's not a very good tech talk. So I looked into it, and we're just not going to do it. So when we want to take a look at how to do things, how to go beyond the basic structure we had, which was Apache and ModPerl, Mason, all these old stuff, what did we do? First thing, we're running Nginx as a reverse proxy. We're running micro WSGI, which you might notice this says WSGI, not PSGI. Micro WSGI started with supporting WSGI, which is the same protocol in Python. But because it is so similar, they added support for PSGI as well. So micro WSGI runs PSGI and WSGI. We're using it as a dedicated web server. We have a lot of internal PSGI frameworks. We're using Dancer or Dancer 2. We have our internal PSGI app and our internal PSGI framework. We do a lot of emulation, a lot of mocking, a lot of faking, checking, fixing, improving. And our old code basically, even though it's under PSGI, thinks that it is maybe under Apache, maybe running Mason, stuff like that. And eventually, it gives us durability, and it gives us decoupled divergence, where we diverge from the request to the different subsystems where each one has its own mocking to let it run simultaneously as with the newer stuff. It looks kind of like this. The web server, I'm really simplifying here, but basically a web server comes in, there's a lot of middlewares to do a lot of changes and fix-ups to the requests and to different objects in the system. And we have an internal PSGI app, which in turn forwards it to different applications. So we will have this nice PSGI compatibility over the old Mason framework. We will have a Dancer application. And you can think of this as reverse proxying all the time, which is something that is very easy to do in the PSGI protocol. So our main app is as if reverse proxying onwards to a different layer. And some of these will run old code, some of these will run new code, and so on. So we effectively have 3 different frameworks here running at the same time. It works flawlessly. Very nice. So this is kind of like, this is what I promised. A few tricks that we use as part of this. And I'm running a little bit just so we would have time to ask any questions, because I might not have nailed the specific interest that you have in this. So I would like to leave a few minutes for questions to cover this. But here's a couple of tricks that we use. And I really like these tricks, and I'm really happy that I can share these. One of them is that we preload a lot before pre-forking. which is something that is very easy to do in PSGI. Because you need to construct this code reference, your app, and serve it to your server, anything that you load beforehand, if the server forks, you've just preloaded before forking. You can save a lot of memory. So, you know the builder thing that I showed that creates this nice app? I can load stuff before in memory. So I can just say, require this class, import stuff from it, and I just loaded stuff into memory. A lot of stuff, I created this app, and I sent it to the server forks. All of these forks now have access to the same thing. I didn't have to load again into memory. This is a very, very, very cool trick. You can save a ton of memory with this. And we have such a huge infrastructure. We have over 4,000 MySQL slaves. Yes. It is insane. This is very important, as you can see. We do some asynchronous cleanups. Awesome stuff. So you need to clean up your context and your global state and a lot of stuff like that, which we usually do at the end of a request or at the beginning of a request, depends how you write your stuff. But some web servers, specifically MicroWSGI, supports asynchronous cleanups, where it received the request, it did the thing, it returns a response, and then it cleans up stuff. So your client already received, the user received the response, and after the user received the response, the server starts cleaning up stuff. And it allows you to tell it what you want to clean up, so you can ask it to clean up your state. This is how it looks like. When we return our application, we create this subroutine for different cleanups, different handlers, different stuff, and we set up in this environment hash a very special key called PSGI-X cleanup, which is an extension for cleaning up code. And we just add to cleanup handlers all these cleanups that we've had. And what happens is that once the user receives a response, the server will actually run these code references to clean up stuff asynchronously without bothering the user and without hanging up their request. I love this smart authentication. Like I told you, you can have your own auth basic, which is something incredible. For example, we have our own authenticator that says it uses constants for deciding what the server does, because we have different servers doing different stuff. And if it does one thing, we can return a check, or we can return the result of a specific check. If it does a different thing, we can return the result of another check. So basically, depending on what the server does, we can authenticate you according to different mechanisms. It could be according to a database. It could be according to LDAP service. It could be according to Active Directory. It could be according to some third party. It could be whatever we want. Auth basic originally is just a stupid password file. This changes to whatever we want with the same protocol. Very cool. And you have no ID. I love this. Does anyone know this? This is a much longer conversation in which he says, oh, so your password is Hunter2. And he says, how do you know it's Hunter2? He's like, I don't know. I'm just seeing stars. I copy-pasted it. You see it's like a whole conversation. People on IRC, what can I tell you? But we actually use this. So if you're using a development environment, which is basically your KVM at the company, every developer has a numerous amount of KVMs for different server roles. We actually have a check that if your server is a dev server, as in your KVM, we will actually allow you to use Sanhash or Hunter2. Which is, it's the encrypted version, 7 stars. So we support both of these. So for example, you're running a development machine, and you're trying to use some service which needs authentication, and you want to use, I don't know, some script on your machine, or a curl request, or you go into a friend's computer. You're not going to remember your actual password in the system. You're not going to write it in the command line. So this gives you, if you're in development in the company itself, you put in your username, Hunter2 or Sanhash, which is just the password you can write in the same, it's all in the same line of the keyboard, or 7 stars, and it will work, which is really, really nice. If I go to someone else's computer and say, well, go here for a second, it pops up the authentication. I don't fucking remember my password. It's like a corporate password, so uppercase, lowercase, numbers, characters, Unicode. I don't know. So this is very, very, very cool, and this is something you can do because we have this in code. It's really easy to encode. My very favorite. The gem. It's called Sanity Destroyer. The description is this. What Sanity Destroyer basically does, this is a trick that you can write yourself. It is insane. It starts a new state. It keeps an object. It allows you to check if that object was destroyed, because when you close a scope on an object in Perl and it has no other references, it actually runs a destructor. The destructor cleans up the state. Why is this useful? Because you can save that object somewhere in your request environment. Now, when a request comes in, we check whether the object still exists in memory. If the object exists in memory, it means it wasn't cleaned up. It wouldn't be cleaned up if there's a memory leak. So what this gives you is the ability to check for memory leaks in your application. Very nice. So the conclusions, I'm going to end with this. Plaque provides us with a durable decoupled divergence, which allows us to be flexible and to be adaptable to new technologies, which is very, very important for every big company. Now, new technologies, which is actually the key, they must have a migration path. And if they're not able to allow you to easily migrate, or they're not flexible and adaptable, then you won't be able to use new technologies. So this is something that is very, very important. And I'm just showcasing this with Plaque and with booking. And eventually, the achievement that we unlock here is the ability to continue to write new stuff, to create new things, to continue to move the company forward and the product, whatever it is, without worrying about, well, we have to use this old shit that existed since 1995 and stopped being maintained in 1996 or whatever. And a lot of these companies actually do stuff like that. Red Hat. Now, this is my conclusion. Development is actually the act of moving forward without forgetting your past. And I don't know if I mentioned, you can come talk to me afterwards if you're interested. That's it. Thank you. Does anyone have any questions? Really? Nothing? No questions at all? Not even trolling? There we go.
Can you try preloading with shared?
I cannot hear you without the microphone. I can't.
Sorry. Have you tried preloading with shared memory instead of per each thread for the forking daemon?
Well, we're running micro-WSGI in a single thread, which then forks. So we're not running multiple threads, so there's no need for that shared memory. Any other questions? Really, feel free. You can ask me anything. It doesn't have to be about this. Nothing, really. All right. Last chance. Another brave soul. Happens to be the same instance of the soul. Yes?
OK, so what's your preference about the server in front of PSGI app? Is it Apache or Nginx? Or something else?
So we're running micro-WSGI, which basically runs the Perl app. And it runs only the Perl app. It is very, very fast, and it has that asynchronous cleanup, which is really, really good if you have some state that you want to make sure that you clean up. There are different setups in web programming where you don't have state, and that's fine, that's great. But if you do and you maintain it using context and states, it's tricky, and having asynchronous cleanup is very, very good. I like Starman as well, which is a very performant Perl-based web server. And I love Twiggy because then I can write event-based programming inside. Although with micro-WSGI and the PSGI protocol, you can still write some asynchronous stuff as well. So we do have some services that are non-buffering and streaming, even though it's not using an event loop. So it's using the ability in PSGI to stream output. So we do have that as well. I just like event-based programming. So Twiggy is great for that. There's a lot of tricks I like doing with that.
So what do you do with the SSL?
SSL, so this is a good thing to ask. These Perl-based web servers, almost all of them, don't support SSL. I don't know if micro-WSGI supports SSL, but Nginx does. So we use Nginx as a reverse proxy, which if you have SSL, it will do that with the client, and then it will return a response in non-SSL, which sits on the same server, so it's OK. I have seen people use reverse proxies that converse in SSL and then return a non-SSL request across continents. But I will not share which companies those are. Not us. Very important.
Okay, and one last question.
There are so many other questions. I just don't know if you could. You know what? Okay.
Okay, so have you used PSGI application to create a load balancer between other PSGI applications?
Well, our PSGI application, our main PSGI application, does do something like that. It basically decides, it sets up stuff and then decides which PSGI application does handle that. I've actually gone further and embedded for some paths another PSGI application that just does that as well, for even doing that again and again. Basically, if you do web long enough, you realize that web is basically proxy, 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 proxy result. So once you understand that, adding more stuff in the chain doesn't really matter. And in this case, it's just code. So you can think of it logically as proxying again, or you can think of it technically as running another function. Who cares?
Who cares? Maybe Google for the time to first byte?
I shouldn't talk about Google. But when it comes to stuff like that, that is actually not an issue if you structure your application correctly and you take that into account.
So do you lie by sending a first byte and then continue?
You can do that with PSGI, though. That's the thing. With PSGI, you can do that. You can say, I want a fully streaming asynchronous response. First return the first one, then run the rest of the request and return whatever it responds with. And that could be buffered as well. That could be non-buffered streaming as well, if you want. It's really nice. It's very possible. One thing you can do with streaming non-buffered PSGI is that you can get a file upload, get the first chunk, check its magic with file, whatever it is, whatever utility you use, to identify whether this is a file extension that you're willing to accept, and then send it back. So, for example, Gmail doesn't check in file uploads if it's a zip file. It checks if the extension is .zip. If you change it to .zi underscore, it works. But if it will actually use a non-buffering server with a non-buffering protocol, which is streaming, they can get the first chunk of it, check if it's actually a zip file according to the file magic, and then respond with, whatever you called your file, it's zip, and no. But it doesn't do that. With PSGI, you actually can do that. I'm assuming they're using something which theoretically could, but I don't know what it is. Any other questions? All right. Thank you very much again.